Alright, simultaneous equations, the way that was taught in class is actually the elimination method, okay? So we want to eliminate either the x or y variable usually, so that you're left with one and you can solve with that equation. Okay? So the main thing is that you gotta change the coefficient and show that the coefficient, meaning the number in front of the x or the y, is the same first for both equations. Then depending on the signs of the coefficient, you are going to either add or subtract the equations from one another. So now let me ask you, which one do you want to target? You want to target the x coefficient or the y coefficient? It's really a matter of choice. X. Is it? Sure. So now one is 8, one is 2. So naturally you want to multiply the smaller one to become the same as the bigger one, right? So let's say this one 1, this one 2, right? I'm going to take number 2 and do what to it? Times 4 to every single fella in there. Okay, so you got to do it very carefully to get 8x minus 8y equals to 7 times 4, 28. So to me, I just retain it as equation 2 lah. Don't confuse yourself with so many labels. Okay, so now we look at 1 and 2 here. Okay, so now that the coefficient is the same, we either add or subtract the equation. Bearing in mind we're eliminating them, now it's positive 8x, positive 8x. Should I add or subtract them? Subtract, right? Positive 8 minus 8, then you eliminate 8, I mean the x. So I'm going to take 1 and subtract away 2. So be careful guys, you're doing subtracting. You must do it for every single term. So 8x minus 8x, 0x left. Now the tricky one. 1y minus negative 8y. You have double negative. So what does that leave us? Positive, right? So actually, I say again, actually it was y minus negative 8y from the top to the bottom. Can you see that?
Yeah.
And then 1 minus 28. So this part that I was telling you to be careful of, double negative, you get positive. So y plus 8y actually equals to... Huh? No, I mean the right hand side. Negative 27. Hence you add this up and you realize that I have eliminated one variable. That's the point. That's why it's called elimination. Minus 27, so y is negative 3. So with this value of y, I let y be negative 3 into any of the equations. You can find your x. So let's say I put it into number 1 I substitute into 1. What do I get? I get 8x plus negative 3, which is the y that we just found. And then we can find x. So 8x bring over to give you positive 3, yes. So 8x equals to 4, solving 4 over 8 half. Okay, so we have found our x, we have found our y. So we have solved for both variables. Okay, so I'm going to record this now. So I have 4x, 2x. I'm going to take equation 2 times 2. I'll just quickly do it. Yeah, it's already recording. Too late. Then I will subtract to get 5y equals to minus 10. So y is negative 2. And substituting back, x is okay, I don't do so fast. 2x plus 2 equals to 9. X is 3.5. Okay. Okay, recording. So basically this question, still elimination, but now you realize I cannot just do one step to make the coefficient the same. I need to change both of them at the same time. Okay? So like what some of you have already done or are thinking, I need to find the highest common factor among the two. For example, 3 and 4.
12.
The highest common factor is actually, sorry, the lowest common multiple, sorry, made a mistake, is 12. Okay, so I will take equation 1, I times 3 to get 12x plus 15y equals to 21. I take equation 2 and I times 4, the opposite of each other. 12x plus 16y equals to 20. And then we are almost ready. Now we clearly have 12x for both. Do I add or subtract the two equations? Okay, I subtract, so 1 minus... Alright, so eliminating or subtracting, I get negative y equals to 1. So y is negative 1. Then I substitute y equals to negative 1 into either 1 or 2, doesn't matter. I get 12x plus minus 15 equals 21. 12x is 36, right? X is 3, right?
Yeah.
Yeah.